So let's turn to problem 3. And problem 3 says that in this problem our dedicated trig student is vacationing in a large city that has many skyscrapers. He decides to measure the height of one of these buildings by measuring the angle at a point A, and then that's the angle from the ground up to the top of the building, and then moving to point B and measuring the angle again. By knowing these angles and the distance between A and B, he can determine the height of the building. See the sketch below. Now in the sketch below, you can see that we have A, B, and C along the ground level, and I'll put a T at the top of the building. And so this is going to form some triangles that we need to use or solve in order to answer the question of how tall is the building. So I guess first of all we can label H as the height of the building. And now we also need to know the distance between A and B, and that probably should have been stated in the problem above, but I'll go ahead and put it down here. The distance from A to B is 1,050 feet. Okay, so that's his measured distance or known distance along the ground between the two spots or sites where he looked at the top of the building and measured the angle. Now, to get started on this, we want to look at the right triangles. But first of all, we see a triangle here, A, B, and T, that we know an angle and we know a known side. So triangle A, B, T. We have a known angle of 22 degrees. We have a known side of 1,050 degrees. But unfortunately, ABT is not a right triangle. And so we can't use the trig that we've learned so far. So we look for right triangles. And you can see two of them here. One triangle is from BCT. And in triangle BCT, we have a known angle, 31 degrees, and we have our unknown H side that we want. So all we need is a known side. Unfortunately, if you look at this problem statement, we don't have a known side. So we don't have enough in triangle BCT to solve the problem. So no known side is a problem here. But that's what we've got. So we have to look then maybe at another triangle, ACT. So look at triangle ACT. In ACT, we see that the AB part is known, but the BC part is not known. And so again, we have the same situation, no known side. So it seems like we've got a problem compared to the first two examples that we looked at, and we do. And in fact, in this case, we're not going to be able to solve this directly with one triangle. We're going to have to use both of those right triangles, BCT and ACT. So we look at the two triangles. Let's start with BCT. And we see that there's this distance along the ground that's not known, but it does seem to be, well, we need it to get the distance from A to C, and that's going to be needed when we get to the next triangle. So let's call that X for now, and we'll have to write our equations then with the trig. We're using this unknown X. So we've introduced an extra variable, x, but there's no way to avoid that using these two right triangles. So we can use the triangle BCT, again, getting back to that. Triangle BCT. The H is on the opposite side, and the X is on the adjacent. And now that's opposite and adjacent relative to the angle 31 degrees. And so we can say that opposite and adjacent, we need to use tangent. So we can say that H over X is equal to the tangent of 31 degrees. Okay. So that's equation 1. And we get that from triangle BCT. Now we can do a similar thing with triangle ACT. ACT, the H is again on the opposite side. And the, well, it's not the X, it's 1050 plus X is the adjacent side. And so now we can write H divided by 1050 plus X is equal to the tangent of 22 degrees. And so we've got another equation, equation 2 I'll call it. And so now we have two equations and we have two unknowns. At this point, again, the trig is over now because all the trig was doing was allowing us to set up these ratios, give a name to them, and the calculator will give us a value for the trig functions. So the trig has been done. So now we're back to the world of algebra, but it's a little more complicated algebra than what we encountered in the first couple of examples. So we have to solve this two equations and two unknowns, which back in algebra you were probably shown several ways to solve those, and we need to at least remember one of them. So one way to solve the equation would be the set of equations would be to solve one equation for some variable. I'll solve it for h. I'll solve equation 1 for h, and then substitute it in for the h in equation 2. And that will get rid of the h for now, and we'll have one equation involving just the variable x. So let's do that. I'm going to solve the equation 1 for h, and that gives me h equals x times tangent of 31 degrees. Now, once I have that, I can replace the h in equation 2, substitute into equation 2, and that will give me h, which I'm now going to replace that by x tangent of 31 degrees, all divided by 1050 plus x, and that's going to equal to the tangent of 22 degrees. So now we have one equation, even though it looks kind of complicated, we have one equation with only one unknown, x, and if we apply our algebra skills, we'll be able to solve for x. So, to do that, we need to, first of all, get the equation written so there's no x in the denominator anymore. So we need to multiply both sides by 1050. Multiply by 1050 plus x. I misspoke there. 1050 plus x. If I do that on the left-hand side, all I'll have left is x tangent of 31 degrees. And on the right-hand side, I'll have tangent of 22 degrees multiplied by the quantity 1050 plus x. Now, this is the equation that we need to solve for x. Now, this equation looks kind of complicated, but tangent of 31 degrees is just a number. Tangent of 22 degrees is just a number. So this equation is really kind of like the following. You've got a number times x, like 5x, equals another number on the other side of the equation, let's say 3, multiplied by 1050 plus x. So this is not our equation, but it's like our equation. And the one I've written over here on the left is much simpler, and when you look at that, you know how to solve that exactly. You distribute the 3, you collect your like terms of x, and you divide through by the coefficient. We're going to do exactly the same thing over here on the equation that we have. So in the first line, I'll just distribute the tangent of 22 degrees on the right-hand side of the equation, and I'll have 1,050 times the tangent of 22 degrees, plus I'll have tangent of 22 degrees times x. Okay. So now I have distributed on the right-hand side, and I need to collect the x terms together on the same side of the equation, so I need to subtract the tangent 22 degrees times x from both sides, and that will give me x tangent 31 degrees minus x tangent of 22 degrees equals 1050 tangent of 22 degrees. So now we have all of our x terms together on the left-hand side of the equation. And so we're sort of in the situation of having 5x minus 3x on the left-hand side of the equation. So when you have that, you just collect the like terms by subtracting the coefficients in this case, or another way to think of it is factoring out the x. Either way, you'll get tangent of 31 degrees minus tangent of 22 degrees. And that's a whole quantity times x, because we factored out the x, and that equals the right-hand side, which I'm going to leave as is. And the final step is to divide through by that number that's multiplying x, the tangent difference there. So x then will be 1,050 times the tangent of 22 degrees divided by the quantity tangent of 31 degrees minus tangent of 22 degrees. Now, you may have chosen to solve this by going ahead in the very back up here at the top equation and using your calculator to find out what decimal number the tangent of 31 degrees is and what decimal number the tangent of 22 degrees is. That would have looked more comfortable perhaps, and you certainly are welcome to go that way. The disadvantage is you have to copy down those 4-digit numbers over and over instead of just copying tangent of 31 and tangent of 22. At any rate, that would have been another option. Now I'm going with this one, so that now I can put this in my calculator and say what the value of x is. So let me do that. The value of x will be 2,115 feet. And that's rounded to the nearest foot. Now, once we have x, that's really not what we wanted. In fact, we didn't even care about x in the statement of the problem. We just wanted h. But if we go back to equation 1, we can solve for h, because h over x is equal to the tangent of 31 degrees. That's equation 1 again. And now we can put in what we now know x is. So h over 2,115 is equal to the tangent of 31 degrees. And we solve for h. H equals 2115 times the tangent of 31 degrees. And that comes out to be 1,295 feet. So the skyscraper is 1,295 feet tall. And that is the end of example 3.